Hello, this is Stephen from Design Fusion. We're North America's largest Siemens PLM software reseller, and today we're going to talk about the MoldWizard product. Now, the MoldWizard product puts together a set of tools to speed up the redundant and repetitive tasks that designers face every day. A lot of time it can be spent interrogating parts for tooling, making adjustments to the parts, and setting a parting line. This is the Siemens NX product using the MoldWizard bundle, and we're going to load up a sample part we've created, a 1970s Harvest Gold hairdryer. Now this part has several features, telescopic features, shutoffs, and things that you see in the typical molded part, and we're going to interrogate this part. We go to the MoldWizard tab, and you can see we've got a wide range of tools. The main section, parting line tools, cooling, mold tools, validation, mold drawings. But today we're going to focus on the part validation because this is where designers spend a lot of time and effort interrogating the part. So first we're going to go into the mold part quality, which gives you a couple of checks. You've got the check for undercuts, we can turn that on or off, and draft angle, and we can type in a specific angle we're looking for, like a minimum. So I'm running this check with a 1 degree setting, and this is checking the draft angle of the surfaces. And you can see in the checkmate tools here, I've got some surfaces that flagged as low draft conditions. So we've got 0 to 1 degrees, 0 degree faces, and below that we've got some -1 to 0 degree faces. So you can see as I select on these faces, they're highlighted in the information boxes. That's just to lead you to that area. Basically, this tool is more just for illustrative purposes. You can see when I click down and expand this other list, all the faces will highlight as you go over them. So this is like a quick interrogation tool just to get you in the general idea, and we'll show you more in-depth analysis after this. So now that we've looked at this, we can turn off the checking the draft angle, and we're going to switch this to check for undercuts. Now you could run both of these at the same time, but just for speed's sake, I've separated these out. So we'll run that check. Now you can see it's flagged some undercuts. So it'll put one marker on the whole part to tell you this part has undercuts. Now when we expand that, we can go to each area that's pointing out. So when we zoom in on the highlighted one there, we can see that there's some faces that are undercut due to that feature that will need some sort of lifter or mechanism to demold that part. We also have the crossover faces. Now this highlights the general area, and then same thing, you zoom in, you expand that, it'll show you the faces, and the more you zoom in and as you highlight, the flags will pop up. So this is telling me I have areas that need an isocline curve or some sort of parting line split to work properly. Now we also have the undercut edges, because you can have faces that aren't undercut but do have edges that are undercut. So this is actually split into a different part of the tree. Now we'll close this up. So that's our visual reporting tool. But besides that visual reporting tool, we also have check regions. But another thing we'd like to do on this part is check the wall stock. Thick wall stock in a plastic part creates a lot of sink and high cooling times. So I'm going to drop this spacing down a bit just to get a finer display, and we're going to use a rolling ball method to calculate this. Now there is a ray calculation method, which is a different way of doing it, but the rolling ball is quite quick and gives us a result that we can review quite quickly. Now it's just running a few seconds here. So you can see we have blue and some greenish areas, blue being the typical wall stock, the green being thicker. But let's change these options so we get a better visual representation. So we don't have 1-inch wall stock, so let's try 0.3. We'll apply that, and that's going to change the color range. Now you can see I've got some ribs in there, with the maximum thickness being 0.3, that red zone, the yellow zones being quite thick. If we flip this over, you can see the flange around there is thick as well. We have a clip over here that's very heavy wall stock, and the bosses obviously where they intersect the wall. So if we want to go a bit deeper into this interrogation or make it a bit easier for someone to see if we do a screen dump of this, I'm going to set that at 0.18 and the high of 1-inch wall stock. Now what that's done, I've set the range outside of what the thickness of the part is. So now it only shades what's 0.18 or thicker. So if we make screen dumps of this, we can send those off to the customer or to our engineers and say, you know, we're going to have cooling problems in these areas, high shrink, things like that. So now what I'm showing you as well is with the rolling ball method, when you pass your cursor over a face, it shows you the ball that fits in there and it prints out what thickness of wall stock you have. So if we go in here and look at some of this edge wall stock and the tabs, you can see the ball changing size, and that's simulating the analysis that it did for the color chart. And if we go over the wall here, or if we go over to the rib below, you can see the information presented to you. Very handy tool. So now we can close up this result, and now we can get more in depth into this part. Now this part has a lot of seal-off areas that a designer would typically take a while patching these holes in to split the core and cavity apart. Now when I run a calculation on this, it's finding the core and cavity for me. And if we go into faces, we get a report based on the draft angle limit we've set of what are positive faces, vertical faces, and you can see as I highlight them, it shows you them on the screen there. These are positive draft faces less than 3, negative less than 3, etc. So this also allows us to make translucent changes to the surfaces, so we can really point out faces we want to show on a report. We also have the ability to map those colors directly to the faces based on the results, so we could save the part off at this point and give it to someone else and say, you know, these are the areas you need to look out for. And you can see in there we've got a gray wall, which is saying that's vertical draft that rolls into the radii. We also have face draft analysis, which when you're first interrogating a part, you may not know the die draw. This lets you quickly simulate die draw angles. Again, I'm making certain areas translucent here, and I'm setting the shading limit at 5 degrees. So as I move this slider, you can see that 13.2, and then the shading cuts off. So this lets you visualize where the draft is on the part. We can also select directly on the part faces and get a report of the angle at the location. So if I pick that face, you can see it's 30 degree normal at that location. And the output here I've got set to both, so it will save the isocline curves and these reports when I apply it. Now here I'm going to tip the draft, and you can see how it's generating isoclines in the lighter color. So that area would be undercut based on the draw that I've picked there, and the shading of the faces adjusts. Now I'm going to cancel that out. I'm going to regions. So now this is where you see the intelligence of it understanding what's core and cavity. It's already picked cavity, so if I turn that off, you can see what's core below. I can do the same with the core side. I can make that translucent, just see what the cavity would look like. You can also see the orange line where it's determined the parting line, and what I'm clicking on here is crossover faces. It's showing me that it has crossover faces at the end. So if I turn off the core and cavity, zoom right in, those shaded faces, it's telling me that there isn't a true parting line there. I need to do something with that. I'm going to turn those colors back on. And right now I'm going to set the colors to what is core and cavity. And if you select these, you can actually pick a different color if these aren't your favorites. And you can see the crossover faces have been placed in a cyan color. I've got parting line edges turned on too. So right now it's showing a parting line at the top, and that's not where this would naturally be. So we go into the face split. Now there's different options in how to create the parting line on the face, but we're going to use the isocline, which will find us the 0 tangent line. And as I click these, it's generating that split for me. I'll say OK to that to split those faces. And there you go, it split them. So I could rerun the analysis, and you can see it says unknown faces now. And I could rerun the analysis and force these to get calculated by the system. But since I know where they lie, I can assign these faces singly to the core or cavity region manually like this. So now you can see here the parting line is defined at the tangent split. And you can also see that the rest of the parting lines are defined as well. So if I turn off the core and cavity, you can see this orange highlight showing you where the core and cavity split lines would be for each feature. Now if we go under information, we can get information about each face. So if I select a single face, you can see minimum, max, average angle is 5, or another face there, max is 86, minimum 5, average 46 across that curvature. We can also check the model properties, dimensions, and volume, and we can also check for sharp edges. So if we click that and specify the maximum sharpness that we want, the software highlights edges that have that condition. So if we rotate in to that one highlight area, it's calling out a sharp edge on the cavity here. The reason sharp edges are important to investigate is it's hard to get certain small cutters down in deep cavities, and also sometimes in certain situations where the plastic tapers to a very sharp edge, there's no way to get the plastic to fill that area properly. So you can see here in the section we've got a sharp corner there, which when we machine that with a ball cutter we would leave a radius, so we may have to go in and use EDM burning process if the customer does need that sharp at that location. So I'm going to leave this section on so we can see that area. We also have some other checks here, and here we're checking the minimum radii sizes. So you can see here with these radii that are showing up, because of the way they're going to be formed on the cavity, they're not really a machining issue. The space between the slots would be a bigger issue. With those tools, we can also use them to find the minimum radius of machining down inside a cavity, which we can get into later in a different episode. So that concludes the molded part validator initial look. Stay tuned for our other videos in this series, which will get more in depth than some of the other MoldWizard tools. Thank you.